Hello guys and welcome to my first video on this channel, our physics GCSE channel. So as I said, I solve past papers and show you everything. My mark in October-November 2010, variant 1, paper 3 was 71 out of 74. I made a mistake and I corrected it basically because I promised that I will correct my mistakes and show you the explanation for each question. So just let's start our video. First question. It says, an object of weight W is suspended by two ropes from a beam, as shown in figure 1.1. The tensions in the ropes are 50.0 newtons and 86.6 newtons as shown. In the space below, draw a scale diagram to find the resultant of the two tensions. Use a scale of 1.0 centimeters equal 10 newtons. Clearly label the resultant. Yeah, by the way, the key is red and blue mixed ink tick. It means powerfully perfect, and red means excellent. So yeah, let's go. This one was powerfully perfect. How did we do it? First off, I just have the mouse came right here on my iPad, suddenly in case we wanted to check something. And yeah, okay. And here's question 1. I made they said the scale is 1 centimeter, which equal to 10 newtons. Here we have 10 newtons times 5 equal 50 newtons. So 5 is to 50 newtons is 5 centimeters. So we draw here 5 centimeters line. You just draw it, and then from here you put the protractor, just like that. The 90 okay, so let me bring my protractor and show you. This is 5 centimeters, so we put it like that, and the 180, as you can see, just let me position it. Okay, perfect. As you can see here, it's just matching the last point of the 5 centimeters line, and this 180 line is matching with the line. We measure till 90 degrees, which will be basically here, right here, 90 degrees. So we put a point, and they wanted 8. Oh wait, why did I make 90 degrees? Sorry. 60 and 30 are separating the two forces. 60 and 30 is 90 degrees. That's why, okay? Then we basically, when we put that point, we bring the ruler and try to put it like that. 1 second. Go. Okay. So you just put it like that. At the point, at the 90 degrees. Surely it must be with the point of the 90 degrees here. And you basically measure 8.66 centimeters, and then you just connect the line like that. So after doing that, you basically would have two lines without that parallelogram. So all you have to do is, after doing that, you bring your compass, put it on the starting point, put it like that on the ending point and the starting point of the 5 centimeters, and then just make it at the same opening and bring it at this line, make an arc, and then you measure the same distance right here for this 8.66 centimeters line, and you put it on the other end of the 5 centimeters, and you make an arc, and then there will be, as you can see, the signs of the arc, but I just deleted it after completing it. The intersection point between the arc, you connect it to the center of the angle right here, and then you just continue with lines, a parallelogram. And then you can just delete the arcs or leave them, but I prefer deleting them. And you measure the length of this line with a ruler, and for me it was 9.9 centimeters, which is equal to 99.0 newtons. So that's the first question done, perfectly done. Now if you move on here, 1b, we're done with 1a, the drawing. For 1b, they said find the value of the resultant. As we said, 99.0 newtons or 99 newtons. How did we find it? We found it by measuring the length and then converting it to newtons. State the direction in which the resultant is acting. As you can see here, the resultant, which is this one, this line, the W, it is acting vertically, it's not horizontal, yeah? So basically it's right, it's vertical. Let me check the masking for that. As you can see here, 1A, you can't understand anything from the masking because it's a drawing. For B, we found 99, they said the value is between 98 and 102, so it's perfect. For C, they said vertically, up or opposite or wherever, but it's vertically. So we have these three questions are done right. Now, question D, they said state the value of W. As the resultant is 99, the weight that is pulling that resultant must be at the same force because it's pulling all of it. So it will be 99 newtons. And let me check here. D, his B, our B is 99 newtons, so true. A car travels around circular track at a constant speed. Why is it incorrect to describe the circular motion as having constant velocity? For me, I answered because velocity defines direction and magnitude. So it's a vector basically. As here, for 2A, they said constant velocity must be in a straight line direction, or the direction of motion is changing. So they're basically saying that velocity must be changing, and speed can be cannot be changing. So this means that why is it incorrect to describe the circular motion as having constant velocity? Because velocity defines direction and magnitude. Now, a force is required to maintain the circular motion. Explain why a force is required. I answered, well, if there is no force present, then this wouldn't be constant speed. Because speed is in one direction. It would be constant velocity. Let us check. If no force, then constant velocity in a straight line or force is needed to change direction. So it's basically as the same as my answer. So I, in which direction does this force act? I said inwards or towards the center. Here, the answer was towards the center, okay, or inwards. Here it is. Good. This one, suggest what fraction. If you notice here, I just answered it excellent, not perfectly excellent. I said by fraction. What provides this force? Friction. They said friction between tires and road. So I basically, it wasn't so perfect my answer because I said friction only, not friction between tires and road. Let me show you how do I. Let me show you how do you understand this. Okay, imagine a circle, and like a car right here. Okay, just imagine this a car. Like that, okay? And it's going like that. It's going like that, okay? If it didn't go inwards, that's the explanation for II, okay? II. If it didn't go inwards, this means, and for III as well. If it didn't go inwards, this means it will continue straight. So it won't be in a circular motion, so it will fall. But it must be, this is the explanation for III right now, okay? So it must be going inwards, just like that, inwards, inwards, inwards. If it was going outwards, then it's going to continue straight. so there must be friction unless it's going to be straight. Imagine yourself skating and there's no friction between you and the ground. You stay at a constant velocity on a straight line, but you don't go inwards because there's no friction between you and the ground. Imagine you skating, that's it. So that's the explanation for I. For I inwards or towards the center, this explains why it needs to go inwards. Because if it didn't go inward, then it's not considered as a circular motion, right or no? So here's the next question done. Next question. Figure 3.1 shows, let me focus. A hydraulic lift in a car repair workshop. Car supports 4 pistons, each of area 0.0 meters squared, piston A area of 0.01 meters squared, and a hydraulic fluid. The hydraulic fluid transmits the pressure caused by piston A, equal to each of the 4 pistons holding up the car supports the pressure. Both of the fluid is the same. The force of 1000 newtons on piston A is just enough to raise the car. Using values from figure 3.1, find the pressure caused by piston A on the fluid. Pressure in solids, or it's equal to force over area, which is equal to 1000. How do you know it's force? By the newtons for sure. Newtons is describing force or weight. Divide 0.01, which is the area, because they said meters squared, and they said for piston A, which is equal to 100,000 pascals. And we made right. Let us check the mark scheme. Pressure equal force over area. Final answer is 100,000 pascals, or newtons per meter squared. I prefer pascals. Anyways, the total upward force caused by the fluid. So force equal pressure times area. So 0.08 times 100,000 is equal to 8,000 newtons. And they said total. So upward force caused by the fluid. They said upward force. So I made 0.08 because here, if you make 0.02 times 4, you will say, why did you miss piston A? I just made the piston 4 pistons. Why? Because they said upward force. This one doesn't make an upward force. Only these. So 0.02 times 8 times 4. Sorry, this is 0.08 times 100,000, which is equal to 8,000 newtons. Total means combined, which is equal to 0.08. I'm explaining here times 4. 0.02. Sorry, and gives us 8,000 newtons. Let us check the answer. 0.08 times his I, which is 100,000, so that's our answer, or 0.02 times his I. So there is a range here, because they said that piston A only can push the car up, so that's why there's a range, but I made it for the 4 pistons, because they said the total. So both answers are true. There's a range between 2,000 to 8,000. Cool. Okay, sorry. Okay. Question B. The weight of each of the 2 car supports is 1,000 newtons. Calculate the mass of the car. Okay, the weight of each of the 2 car supports. Here, let's come back. Car support. So each 1,000 newtons, yeah? So 2,000 newtons. Let's consider that we said 8,000 newtons to lift the car, yeah? So 8,000 newtons to lift the car plus the car supports. So if you want to know the mass of the car, you need to make 8,000 minus 2,000 minus the lifting up of the car supports should give us 600 newtons. But we didn't know the mass yet. So weight equal mass. Mass equal weight over gravity. Let me make you the triangle. Here is weight, here is mass, here is gravity. Weight equal mass times G. Mass equals weight over G, and G equals weight over M. So we basically use this. The weight over the gravity, which is 10, which will give us 600 kilograms. Perfect. Let's check. His II minus 2,000, our II was 8,000, so 8,000 minus 2,000, and they didn't say why it's 600 kilograms, but I explained here, because we divided the weight by the gravity, and it gives us the mass. Perfect. Move on to question 4. A student in a laboratory used the apparatus shown in figure 4.1 to determine the specific heat capacity of aluminum. Here are just some indications, the readings, and define the specific heat capacity. For me, I said it's the energy to change the body temperature of 1 kilogram unit mass by 1 degrees Celsius, or if you can say 1 Kelvin if you want. Yeah, but in IGCSE we use degrees Celsius. So let's go down. For a heat or energy to raise or change temperature of 1 kilogram unit mass or 1 gram unit mass through 1 degree Celsius or 1 Kelvin. So our answer was, they said or. So our answer was one of them, and we are absolutely true. Perfect. Let's move on to the next question. Use the readings above. Those one readings second, yeah, okay, to calculate the specific heat capacity of aluminum. State the equation you use. Now, Q equal MC delta T. So 23,800 equals 0.93 times C, which is unknown, times 28.2. And how did we get 28.2? We made it 41.3 minus 13.1, which is the initial, the change in temperature, delta temperature. So C will equal to 907.5. You can basically do this on the calculator. If you have an equation and you don't know the values and you're just not good in equations, basically just go to the calculator. Okay, here's the calculator. So 23,800 will equal, so you make alpha equal, then 0.93 times C. You can put it as any unknown. So if you want to say, 1 second, let me focus. If you want to say any unknown like shift X or Y, wherever you want to do. So here you go, X, it's alpha X, and then multiply 28.2. Then you just make, you don't make equal, you make shift solve. And here you go, 907.5, and our answer was absolutely the same. And that's how I made it. So 907.5, don't forget the units, joules per kilogram degrees Celsius. Let's check here the mock scheme. Q equal MC delta T. Okay, the final answer was 907.5 or 907 or 908 or 910. We accepted the value of this, and we found that the first value, which is 907.5, so it's the most accurate. Let's keep on for C. Okay, because the student knows it is good scientific practice to repeat readings. After a short time, you can raise out the experiment again, supplying the same quantity of electrical energy, whatever. This time, the temperature readings are initial temperature of block 41 degrees Celsius, and final temperature is 62.1 degrees Celsius. Use these figures to calculate the second value for the specific heat capacity of aluminum. C equal Q over M delta T, which is equal to 23,800 divided 0.93 times 21.1, which is the difference between 62.1 minus 41, which is equal to 1,212.9 joules per kilogram degrees Celsius. And let's check the mark scheme. Yes, exactly, 12.9. You got 12.9. So next up, the student did not make any mistakes when taking the readings. Suggest why the second value for the specific heat capacity of the aluminum is greater than the first. Energy is lost to surroundings and temperature is higher. There's nothing to be explained in this. You can just see it's obvious. But here, more energy lost to surroundings, as I said. Temperature is higher, and that's what I said too. Cool, okay. So suggest two ways of improving the experiment in order to give as accurate as a result as possible. Now here I have no relation at all to the mock scheme, but I'm 100% sure It's right. But like it has no relation to the mark scheme. I made it as you can see only red tick. So this means just excellent, not perfectly excellent. I said repeat and take the average, and our teacher in the class told us to stay in the safe zone in any practical thing. Just say repeat and take the average. And for my second thing, it was just something mental from me. Cover with a bad absorber a shiny surface. If we do this, no energy, temperature won't get higher, as a bad absorber won't absorb any heat. This means temperature won't get higher. So I consider this right. 2/2. We got 10/10 as total. Here the reasons in the mark scheme: insulate block, provide lead, cover by shine. Okay, they said cover with shiny foil. I said shiny surface. There is no such difference, but they didn't explain why. Anyway, I just explained for you how right now. And they said start and finish same amount below and above room temperature. Just some really complicated reasons. I don't prefer them. Next up, what are we having here? Woohoo! Okay, figure 5.1 shows a model cable car system is driven by an electric motor coupled to a gear system. The model cable car has a mass of 5.0 kilograms and is lifted from the bottom pulley to the top pulley in 40 seconds. It stops automatically at the top. Calculate the average speed of the cable car. Speed equal distance over time, 6/40 equals 0.15 centimeters per second. Perfect. Let us check. 0.15 meters per second or 0.15 or 0.15. Oh, sorry, that's a mistake right there. So it's 0.15 meters per second. I'm sorry. Let us correct it. Meters. That shouldn't be considered right. Shit. Okay. Crap. Okay. Let's continue the next question. The gravitational potential energy gained by the cable car. GPE equal mgh. GPE, gravitational potential energy, equal to mass times gravity times height. 5.0 times 10 times 2.0 equal to 100 joules. Don't forget the units. Here, 100 joules, final answer, 5II. Let's go. Moving on. 5III. The useful output power of the deriving mechanism. We know that power is equal to energy over time taken, or work done over time taken. So it's equal to 100 over 40. Energy is 100 joules over 40, the time taken. How did you know? From the givens. That's a tip in physics. Always take the givens. 40 seconds. So equal to 2.5 watts. Let's check. 2.5 watts. Perfect. Here B. How would the electric power input to the motor compare with your answer to A? Greater input and less output. Nothing to be explained, nothing specific. Input is greater. Okay, I said greater input. Output is less, and not a numerical factor. I didn't put any numerical factors here, and I said there's less output as well. So 7 out of 7. Cool. Figure 6.1 shows a part of the path of a ray of light PQ traveling in an optical fiber. PQ optical fiber from glass R. Figure 6.1. PQ undergoes total internal reflection at Q. Explain what is meant by total internal reflection and say the conditions under which it occurs. I said total internal reflection is where incident ray is in a denser medium and the angle of incidence is greater than the critical angle, and where no light would be refracted. Let's check the mark scheme. Incident ray in more dense medium, so in denser medium, angle of incidence is greater than the critical angle, as I said, and there is no light reflected. Perfect. Same reasons I did put. Now B, carefully complete the path of the ray of the light until it reaches the end R of the optical fiber. End R, okay. Here we have glass. We have to label, no labels, no marks. P, Q, I just did it like that. Reflection from Q till it passed out of the optical fiber. So this is considered to be a 5 out of 5 total. Oh, let me check the mark scheme for you. Then check that. The reflection at Q only, no further reflections. I did it at Q only. There is no further reflections, as you can see. Those are just some traces from the things I deleted. Anyways, let's continue because my battery is about to die. 7. The following list contain the name of the types of energy by means of waves. Which one of these is not a type of electromagnetic wave? It is sound waves. Let's check the more scheme. Sound, cool, okay. State the nature of the wave you named in AI, which is the sound wave. So mechanical longitudinal wave, particle, or mechanical, or compression, or longitudinal, or my wave. Okay, we said mechanical or longitudinal, so cool. The remaining of name the missing region. Ultraviolet rays. They said ultraviolet, cool. A television station emits waves with a frequency of 2.5 times 10 to the power of 8 Hz. Electromagnetic waves travel at a speed of 3.0 times 10 to the power of 8 meters per second. Calculate the wavelength of the waves emitted by the television by this television station. Say the equation you use. Like here, the wavelength, it's equal to V over F. V means the speed or the velocity. V over F, which is equal to 3.0 times 10 to the power of 8, equal to over 2.5 times 10 to the power of 8, which is equal to 1.2 meters. Cool, so we have the wavelength, 6 over 6. Now let's continue. Question 8. So question 8, the circuit in figure 8.1 contains a 2.0 volt cell whose resistance you should ignore. There are also 3 resistors, a 3-position switch, an ammeter, and another component P. S, A, B, C, P. Name the component of P. It's a capacitor. Wow, my hands look so black. What the fuck? It looks so black from the camera, but in real life it's not that black. Weird shit. How is it black from the back and not black from the in front? Okay, whatever. Let's forget about this. Deduce the resistance of the circuit when switch S is in position A. So S, let's take it to A. It's basically connected to this, so it's 5.0 ohms. Let us check the more scheme. So let's check here. First question 8. 8A capacitor. 5 ohms for I, good. Position B, R equal R1 times R2 over R1 plus R2, which is equal to 4.0 ohms. There is nothing to be messed with here. 5 and 20, both used, or 25. Anyway, final answer is 4 ohms as we found it. Perfect guys. C, describe and explain what is seen on the ammeter when S is moved at the position C. The rating falls to 0 as the capacitor charges. The capacitor job is normally to charge, so the ammeter won't put any measure, so the needle will turn to 0. Cool, let us check here. Either ammeter reading falls to 0 as capacitor charges, as you said, or no current reading, P already charged, does not, okay. Our reason is more easy, okay, let's move on. D. Now this question is the only question I made wrong in the exam. Question D. With S in position A, calculate how long it takes for the circuit to transfer 320 joules of electrical energy to other forms. I said E equal RIT, okay? So 320 equal 5.0 ohms times I times T. I made I equal 2 over 5 for found I, so 320 equal 5 times 0.4 times T, so T equals 320 over 2, which is equal to 160 seconds. I found myself so absolutely perfectly right, but I found out that it's wrong. Here is the correction. Correction for D. Time is equal to energy over power, which is equal to 320 over phi squared R, phi squared divided R, so equal 320 divided 2 squared over 5, which is equal to 400 seconds. So I got 7 over 10 for this one, 400 seconds. I found a 160 and the mark scheme said 400 seconds. And I found the right answer here. Cool, so here's my mistake. Out of chart. In figure 9.1, A and P are two conductors on insulating stands by the ambient where initially charged. Explain how these charges are induced. They mean the charges that I drew right here. Negative charges are attracted to the positive charges. Unlike charges attract, like charges repel, away of each other. Here, explain how this charges are induced. This obey the law of attraction and repulsion, like charges repel, and unlike charges attract, as I just said. Explain why the charges at X and Y are equal in magnitude, because the charges are equally acting. One charge for one charge. That's what I said, and I don't care about the mark scheme. I'm sure that's right, okay? Because I checked more than a resource. Anyway, for 9AI, negative at left hand end, here we go. Positive at right hand, and I made it at right hand, absolutely right. Cool then. II, positive charge on A attracts electrons, negative charge equivalent. So this means they are speaking about the law of attraction and repulsion. I just made it so much easier with one idea. Okay, they said the idea that each electron leaves behind an equal and balanced proton. I don't know why do they make it complicated. I just said one acts for one, or one charge for one charge. Anyway, B is not connected to Earth with a length of Y. Explain what happens if anything to the charge at X, which is at the negative side. I said nothing. Let's check the mark. Nothing. Okay. II, the charge at Y, which is at the positive side. The positive charges are cancelled due to upward electron flow. Let's check here. Positive charges cancelled, neutralized by electrons. Negative charges flowing up from Earth. Okay. Alright, we made it right. Cool. Let's move on to 10. We're almost done. So, emissions from a radioactive source pass through a hole in the lead screen and wherever. We don't care about the magnetic field here. This is about atomic physics. Radiation detectors are placed at A, B, and C. They give the following readings: A, 32 counts per minute. B, 543 counts per minute. B, 396 counts. C, 396 counts per minute. And here are the readings after removing the radioactive source. Explain why there are still counts being recorded at A and B and C, even when the radioactive source has been removed, and give the reason for them being slightly different. The mark scheme still admit that it puts some complicated things only for teachers, not for students, so shit on toast. Let me tell you how did I answer it. This is related to background radiation, which are normally found at counts per second with radioactive sources, and the difference is in how people corrected the counts per second after background measurement. That is an absolutely normal answer. Here, idea of like for all of this answer, 10A. Idea of background radiation and random or different and different times, not places, by the way. Like what the hell? Okay, let's keep on. B, gamma because it is undeflected. Detector at B because of high deflection. I said it's beta. Detector at C, beta deflects according to Fleming's left-hand rule. Here we go. Okay, gamma, beta, and beta. So yeah. Sorry, for A it's actually nothing. For B, which is gamma, and C, it's beta. So here we go, we are done with the exam. Congratulations. So now, tips for physics. Listen, and I'll speak about them, but not say them. Peace out. The exam is done. Kaboom! So I got 71 out of 74, which is from A to A star. I don't know if it's A or A star, but just that's the range, I'm sure. So let me tell you about tips in physics. Always, just always use the givens, and always when he tells you something about practical questions, use equals. Just memorize this word, equals. Equations, change, other, repeat, measure, same. What do I mean? For example, let me show an example. To find extension, we extend spring, then the new length minus original length equal extension. To measure one swing of pendulum, swing it, count the times it swings, use the stopwatch for the beginning and stop when it stops, divide number of swings by the time it took. So basically included every single thing we need right here. So you just that's some PP6 tips. Avoid paradox error or check for zero error, rule or volume. I'll just show you this paper 6 tips I made by myself. Okay, experiments, measure speed of sound on air, stand away with a distance, make a loud sound using the pistol, shoot it, start a stopwatch once the smoke is visible, and stop it once sound is heard. Then calculate the speed of sound using the measurements. Speed equal t over t, and then repeat many times and take the average to be most accurate. To find mass of something, put it in beaker, calculate the mass of both together and beaker alone, deduct the mass of both minus beaker's mass. To find the volume, insert the object in water. To rise of water minus original, which will equal to volume, and we are done. Now density, to find the mass. To find the density, you need to find the mass and the volume by the ways I just stated, then divide the mass by the volume, because density equals mass divided volume. So obvious. Yeah, basically, what else? What else do we have? Radioactive materials are precautions. Precautions for radioactive materials. Store them in lead protective boxes. Use gloves when handling radioactive materials. Avoid exposure. Simple, easy peasy. Finding best emitter. Stick to coins using wax. Oh, by the way, this example is the best example I've ever studied and heard and teach to anyone. And it's my teacher in the school, Mr. Shoki, that told me about it, told the whole class about it. I found many examples on the internet, but I found this the most one that is like exciting, or it's the one that really inspired me to memorize how to find the best emitter. So stick to coins using wax on one shiny and one dull surface. Apply heat once you do so. Start and stop the watch. Stop the watch in the end for sure. 3. One that melts first is the best emitter. So the one that melts first is the best emitter. So basically dull and shiny surface. For sure the dull, because it's the best emitter, because it's the one who will be the most absorbing, so it will be the best emitter, as it's the one that the coin will melt off first. And yeah, basically those aren't all the practical things. Anyways, see ya.